This is our next lesson after factoring. And today is the first day that we're actually going to put an equals and change these into an equation. When you solve a quadratic equation, it can have two possible answers. All right, the next thing, you need to know that the graph is going to be this U-shaped graph called a parabola. Yeah, it does sound like parabola, but the emphasis is at the word rab, so that's where you actually emphasize, that's where you put your emphasis, so it's parabola. That's the correct way. But if you remember it by parabola, Miss Jessup's fine with that. So, they are going to have a characteristic U-shape, whether it turns down and goes up, or whether it comes up and turns back down, it's still a parabola. Every x-squared graph has that same characteristic shape. It has a standard form, and this part, this side on the left, ax squared plus bx plus c, that is the part that we've been factoring. We've been factoring trinomials. But today, for the first time, we're going to actually put equals 0 on there. That equals makes it an equation. Okay. When solving, you're actually finding where the graph of the parabola crosses the x-axis. Now, I know I have two different copies of notes, and I've tried to redo them, but what are these points called? I think they're already filled in on yours. What's the first thing that we call those points? Solutions. Now, I'll pause just a second and say, when you see the word solution, it's because someone has asked you to, guess what? Solve. Okay? So when it says solve, then you're finding solutions. They're also called what? Okay, x-intercepts, roots, and they're also called zeros. Now, the reason that they're called zeros is because unlike most other equations that you've solved, these are going to say equal 0. We're going to deliberately, in most ways that we solve, we're going to deliberately move everything to one side and put everything on one side and nothing but 0 on the other. Most of the time. Okay, not every time, but most of the time, so it's different. Okay, there are three possibilities. Everybody pick your pencil up. So what happens is, if we have a parabola, it can cross and give us two solutions. It can come down, cross the x-axis, come back up through the x-axis, and it can actually touch it 2 times. That gives me 2 solutions. Okay, that's a parabola. Or the parabola can come up from the bottom, turn and go back down, and still touch the graph, and guess what? 2 places. Whether the parabola comes down and goes up, or whether it comes up and goes down, it's still going to have possibly as many as 2 solutions. Okay, that's 2 times. Okay. Some parabolas don't come and hit the x-axis twice. Okay. Sometimes they may only give us 1 solution. And here's what it looks like. The parabola comes down, touches the x-axis, bounces back up, and therefore it only actually touches it in 1 spot, which means it only has 1 solution. Even if the parabola comes up from the bottom, hits the x-axis, bounces off, and comes back down, it still can only have as many as 1 solution because it hit it 1 time. Now, you can have 2 solutions, can have 1 solution, can also have 0 solutions. What do you think it looks like if it only has 0 solutions? It doesn't touch, well, it can touch the y. I'm not really worried about the y. But it doesn't touch x. In other words, it doesn't come down far enough to even touch the x-axis. Okay? Yes. All right, so that's what you need to write down. Write down in your notes. Okay? Does not touch the x-axis. So if it doesn't touch the x-axis, we have no real solution to find. Okay. All right. Now, before we jump into actually getting into the meat and bones of our lesson, I do want to talk to you about squares and square roots. All right. So, I want to talk to you about what it means to square a number, which we've been talking about perfect squares, and also what it means to square root a number. And I'm going to talk to you about those things being what we call opposite operations. When I say opposite operations, that's like if you add two numbers and you take the answer and subtract, well, you're going to get one of the numbers you used to add. Add and subtract undo each other. Is that right? What if you multiply two numbers? How can you undo numbers that have been multiplied? Divide. So multiply and divide undo each other. They're opposite operations. If I start with a simple number like 5 and I square the 5, everybody good? That means that I have two 5s, 5 times 5, and the answer would give me 25. Now I'm going to take that answer 25 and I'm going to undo what I just did. Okay? I'm going to take 25 and I'm going to what? Take the square root. What number times itself twice is 25? 5. I started with a 5. I squared it, took the answer, square rooted it, and come back to where I started. I kind of made a big circle. Does everybody get it? So if you square something, and then you take the square root of it, if you do both of those same things to it, you basically undid what you just did. Now, if I take let's say I take the letter X and square it. That means two X's, right? X times X. And then I take the square root of it. I just squared the letter X. Then I'm going to square root what I just did. What's going to happen in the end? Does anybody know what I get as an answer? Okay. I took X and I squared it, so I got what? X squared. I'm going to take X squared and take the square root, so I should get back what I started with. The answer is X. Here's how I want you to think about it. If those two operations occur at the same time, they wipe each other out. So the square root and the square basically undo each other, and I just get what I had in there out. I could say, what if I take Lord knows I can't draw, take a little puppy, okay? Actually, it looks more like a kitten. Yes, you can laugh because I'm pretty sad at drawing. Oh, hush. I'm going to take this kitten and I'm going to square the kitten. The kitten times itself twice. Then I'll take the square root of the squared cat. What am I going to get out? I'm going to get the cat. Okay? With its sad little tail and its bent, ugly little looking feet. Miss Jessup can't draw. But you take the square root and square it. They just basically what? They undo each other and you just get what you had in there. What if I take the word cow and squared the word cow and then took square root of that? What am I going to get? Cow back. Yeah, you understand what I'm saying? If the two operations occur at the same time, they basically undo each other. It's kind of important that you understand that. Now, y'all have your calculators. You're going to need to find the square root key on your calculator. So, make sure you have it available. All right, let's go back and jump in and get started. I ran to the internet and I said, you know what, I'm getting ready to teach this lesson for the first time. I want the students to have a good example, so I screenshot an example and we're just going to look at it. Pick your pencil up and write this down somewhere. I know you got a little bit of space. You want to get x squared by itself. Today, that's our strategy. Today, that's our strategy. What we're going to be doing over the next few days is we're going to learn a lot of different ways to solve quadratics. When you have a certain problem, you're going to use the easiest method. Someone asked me in the other class, said, are we going to learn to sing a song? And it's going, yeah. I remember somebody singing a song in math class. You're going to be singing about next Wednesday. Okay? Okay. Because there's a song that you're going to use to help you with a formula that can help you solve these kinds of equations. Nope. All right. Here we go. We're going to get x squared by itself. What's the first thing they did? They moved negative 180 over and made it what? Positive 180. They moved it to the other side. Then they had to do what? They divided by 5. So, and the idea is they got x squared, nothing but x squared, equal to 36. Does everybody see that step? That's the step I want to talk about. X squared equals 36. Remember, we're solving for x. We ain't solving for x squared. So how do I get rid of the square? Well, what's the one thing we can do to get rid of a square? Take the square root. Remember, if you take the square root of a square, they basically get rid of each other, and I'm going to get what? X out. But if you take the square root of x squared, you have to also take the square root of what? 36. And that answer is what? 6. But there's 2 possible answers. Pay attention here for a minute. It is true that if you take the square root of 36, you'll get 6 all day long, every day, 24 hours a day, 365 days a year. But my original problem was not square root. My original problem was what? Some number x squared, and the answer is 36. It's true that 6 times 6 is 36, right? There's also a second number times itself twice that's 36. What number is that? What number times itself twice is also 36? I got 6 and 6. I need another number. Huh? It's got to be the same number times itself. Remember, we're doing squares. Ding, 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 ding. It is. So when you have negative 6 times negative 6, it's also the same as positive 6. A shortcut way, instead of saying 6 or negative 6, is you can say plus or minus 6. Guys, that's a shortcut way of showing how many answers. How many answers does that represent? 2. That's positive 6 if you just do the plus sign, and it's also what? Negative 6 if you just look at the negative sign. So that's a shortcut way to show 2 answers. So that's why it says plus or minus. Miss Jessup will remind you with the plus or minus. Now, the last thing I want to do is, on this little bitty easy graph, what does it mean when it says my answers are plus 6 and minus 6? Let's draw that on your paper. Sketch it out. You got space right there. Let's use it. That means that it crossed the x-axis at 2 points. Well, guess what the 2 numbers are? Negative 6 over here and positive 6 right there. That's what that meant. Graphically, that's what it looks like. Now, let's jump in and do some. We know that we're solving for 2 possible answers, but there could also be 1 answer sometimes, or even 0 answers sometimes. We're also going to get x squared by itself today and take square root of both sides. And when you take square root of both sides, you end up with a plus or a minus. Okay, let's see. Oops, wrong one. Nope. Okay, number 1. First thing I want to do is get x squared by itself. Okay, get x squared by itself. Move the 25 over here, and I get x squared is equal to positive or negative 25? Positive 25. I do not want x squared. I just want x. How do you undo squaring something? Take the square root of both sides. Take the square root of both sides. By the way, this was mentioned over on the other slide, and I forgot to show it to you. This only works when you have no bx term. Y'all see this right here on the front, right there above where you are? I think all of your notes are on one sheet, aren't they? No bx term. What that means is, if I have a squared plus b with an x plus c, I have nothing in the middle. I don't have 3 parts. I only end up with what? 2. So if you only end up with these 2 parts and there's nothing x, then this is the easiest method. Okay, so that's why we're using this special thing. It's the square root of x squared. Let's cancel. So what do you get out? X. Take the square root. If you take the square root of the left, you have to take the square root of the right. the square root of 25? 5. Don't forget, guess what? Plus or minus. The very next step after you take the square root, that's when you put your plus or minus. What does this mean? This graph crossed where? -5 and +5. Miss Jessup's going to draw these, every one that we practice today. I want to get through the notes and then let you get started so you have a chance to finish for homework. Number 2. What do I have to do? I need to get x squared by itself. So how do I get this part, just this part by itself? Divide by 2. So this time, divide by 2 first. Divide by 2. What do you have? X squared is equal to 100. I do not want x squared. I just want x. How do I get rid of the square part? Take the square root of both sides. The square root and the square cancel, so I just get what? X out. What's the square root of 100? 10. Don't forget what? Plus or minus. 2 possible answers. There should be 10, not 100. Peppermint or chocolate? Peppermint or chocolate. Okay. All right. If I graph it, it crosses at -10 and +10. I don't want you to lose track of the fact this is a U-shaped graph called a what? Parabola. We're solving for up to as many as how many? 2 answers. Okay? 2 answers today. Number 3. This first thing I need to do, I need to get x squared by itself. I will divide by 3, but is that the first thing I'd want to do? Let's move the 54 first. So let's move it over here. Okay? 3x squared, divide by 3. X squared is equal to 18. Huh. I'm going to need my calculator for this one. Why do you ask, do I need a calculator? Why do I need a calculator? Okay. If I take the square root of 18, it turns out 18 is not a perfect square. But if you just consider this for a second. I've asked students in the past to estimate. 4 to the second is 16. 5 to the second is what? Too much. It's 25. So if I wanted to find out something that was 18, it's going to be somewhere in between what? 4 and 5. So it's 4 point something something. Okay. So my answer is x is equal to the square root of 18 if you keep the square root as your answer. Or x is approximately equal to 4.24. And we can't forget what? Plus or minus. If you graph this, you went 1, 2, 3, 4, 5. 1, 2, 3, 4, -5. It crosses at -4.24, +4.24. Let me show you something. When you give your answer, if you go to more advanced math, when you go to Math 3, when you go to AFM, which some of you are on track to go there, or if you go to Pre-Cal, some of you are on track to go there. This is considered an exact answer, and so they would simply leave the square root over the 18 and stop. This is actually considered an exact answer, and it would be considered the best answer if you were wanting something that was perfect. However, if I graph it on a number line, then this is considered an okay answer, and it's called an approximation. That's why I have the squiggle lines. What do these squiggle lines mean? They mean approximately equal to. Okay? Approximately equal to. So sometimes the squiggle lines, because if you check your calculator, what was the square root of 18? It was not 4.24, was it? Square root of 18 was what? 4.2426. Aren't there a lot more digits besides 4.24? In other words, we chopped it off. That meant that we got an estimated number, but it's not exact. it's okay, and I need it for my number line, but in advanced math, square root of 18 is actually your better answer. Okay. Are we good? Number 4. I need to subtract 36. So when I do that, what kind of 36 do I have over there? Negative 36. Take the square root of both sides. What's my answer? Be careful, this is a trick. Nope. Okay, can you take the square root of negative 36? I had the square root of positive 18. I had the square root earlier, positive 36. I've been taking the square root of positive numbers and getting good answers. So it's the first time we've ever had a negative. Uh-oh. Nope, won't work. Take the square root and put a negative 36 under the square root. Guess what you get? Okay. Okay, this one is no. It's non-real. That means that there is actually an imaginary answer, which we'll talk about later, but there's no real answer. Or no solution. You could do the 0 with the circle through it. I mean, circle with a line through it. What does that mean? I want you to draw this picture. Can you draw this picture for me? What does it look like if the graph has 0 solutions? It comes down, goes back up, and it's not touching anything. This one does not touch the x-axis. So you got to be careful. Pay attention. Those negatives can have a real big meaning. So right here, I put myself a note. You can't take the square root of negatives. So that means I'd have no real answer. That doesn't happen very often, but there are going to be a few that it will pop up, and they'll see if they can get you. You have at least one on your homework tonight that's going to be a non-real answer or no solution. That one does not touch the x-axis. It simply doesn't come down far enough to do that. 4 down. How many more to go? We only got 3 to go, right? The back is homework for you. Got 3 more to go. Nope. Nope. Number 5. And I know I have 2 copies because I changed this problem. I think this is the same as yours, right? But on everybody else's, it's an 8. So we're going to change it to an 8. Change the 1 on me to an 8. And that works for Tyler's copy too. Okay, this time you're going to give me some help. What do I do first? Lexi, what would I do first in this problem? If my goal is to get x squared by itself, but I got a 7 in the way and a minus 8 in the way. What do I do first? Add 8 to the other side. Is that what you do first, Chris? Okay, so if I added 8 to this side, then I have to add 8 to the other side. You all can solve this one. See ya. Good luck. 7x squared is equal to... Now, what do I do next? Easy. Mr. Dawson, what do I do next, sir? Correct. If I divide 7, I get x squared is equal to 4. How do I get rid of the square on my x? I don't want x squared, I just want x. How do I get rid of that? Take the square root of both sides. This is called the square roots method. Then I get the square root and the square cancel, so I just get what? X out equals 2. Don't forget what? Plus or minus. On the quiz, historically, I'll have about 4 students in the whole room that will give me 1 answer instead of 2, because they will forget what? The plus or minus. That's so Miss Jessup will always say, don't forget what? Plus or minus. Okay, oh my goodness, example 6 has got a fraction. Before we freak out though, guess what? This is an easy one to work with. I'm going to minus, and I'm going to keep it as a fraction for now, but if you want to use that, you can. I'm going to leave it over here, so I'm going to add plus 1/4. And it is true, if you want to, You can change it to decimal. If you change it to decimal, it's 0.25. I want you to see what it looks like if you keep it as a fraction. I don't want my x squared, so how do I get rid of the squared? Take the square root of both sides. Okay? Now here's the part that is a little bit new. Does the square root, does it go with the 1 on top? Does the square root go with the 4 on the bottom? Or does it go with both? Both. Can you take the square root of the even number 1? What number times itself twice is 1? 1. Okay, square root also goes with the 4 on the bottom. Is 4 a perfect square? What number times itself twice is 4? 2. So this answer turns out to be an easy, nice number, 1/2. Don't forget what? Plus or minus. So I go to 1 and -1. So I know it's going to be halfway in between. This parabola crosses at -1/2 and +1/2. Everybody good with that? Okay. I need to change the last example because it is different, but I am going to change it from a fraction to a whole number. Everybody good with 1, 2, 3, 4, 5, 6? Okay. I would like you to take the denominator and just black it out. Okay. The process is just, if you use a fraction, you have to deal with fractions, and since this is a different kind of solution, it looks different to start with, I want to work with whole numbers to begin with. So we're going to make that just 36 for now. Everybody okay with that? No, not in this problem. Yes, there's the fraction you can handle is like the fraction we just did. You've got a fraction that works nice like that one. Okay? All right, number 7. This problem is different because this time, where is my x? It's locked in those parentheses. And you can't just go in there, and pluck your x out because it's got a -1 with it, and it's grouped with parentheses. If I wanted to work it out that way, I might could try that, but there is a different way. I'm going to do the roots method. How do I get rid of the square? Right there. Well, how do you undo a square? Take the, how do you get rid of the square? What's the opposite of squaring something? Okay. Let's get this one done then. What I want to do is I want to get rid of that square. So to get rid of that square, I'm going to take the square root of the whole side. So put a big long bar across it. If you take the square root of one side, you must do what? Take the square root of the other side, which is just regular number 36. Now, when you take square, remember the square root and the square cancel. Whatever was under there now comes out, including the x, the minus, and the 1. No more parentheses, no more square. Does everybody understand? That square root got rid of the square part. Okay? What's the square root of 36? 6. Don't forget what? Plus or minus. It's the very next step after you take square root that you must remember the plus or minus. How many possible answers are there? 2. This will be the first problem we've done today where you're going to have 2 different numbers and not just plus or minus of the same number. Because I'm not done yet. How many answers is right here? 2. Positive 6, and then what? Negative 6. But I still don't have x by itself, so how do you get rid of -1? I'm going to add 1 to this side, which means I'm going to add 1 to that side. Whoops. Guess I'll leave that. To get my 2 answers, I must add 1 to how many different numbers? 2 different numbers. Okay, I'm going to hide the negative. Is everybody with me? Okay, I'm going to add the positive 6 to the positive 1. Positive 7. Write that down. Did you write that down? Now, I'm going to hide the positive sign. Now I'm not working with positive 6 anymore. Now I'm working with negative 6. What's negative 6? Add the 1. Negative 5. So this time I have 2 different answers. Here we go. Negative 5 positive 7. My parabola crosses in two places, negative 5 and positive 7. Okay. This is called the square roots method, because guess what we did? Every single solution. We took the square root of both sides, and we didn't forget what? Plus or minus. All right.